Let's take a look at number 41. First, missing positive. So we're given an unsorted integer array. Find the smallest missing possible positive integer. So 0, 1, 2, we got 3, 3, 4, minus 1, 1, 2 is missing, 7 to 12, 1 is missing. Yeah, and we are required to run the algorithms in ON, linear time, and use constant extra space. Actually, the first thing comes to my mind is that I need to sort the things and filter out those non-positive numbers and just to do the check. And it sounds pretty straightforward, but except that if I sort, it's gonna be O(n) log n. So it actually does not satisfy the requirement, yet I think it's worth a try. So I'll just do it at first, okay? Sort. Wait a minute. Sort, but I need to filter out the positive ones. So filter out only the non-positive ones. So positive numbers. This will be ON. And then sort the positive numbers. And then I need to just compare them, right? Just compare them. Okay, for each number. So now the first number should be 1, the second should be 2, the next one should be 3. Right? So yeah, it should be like if lambs I does not equal to I plus 1, I'll return nums I. No. Return nums I plus 1. If it equals to it, then we just move to the next one. And finally, we should return nums dot. If all the for loops are down, it means that it should be 1, 2, 3. It's quite, yeah, 1, 2, 3, 4, 5, just exactly what they should be. So we return the n plus 1, 5 plus 1. Yeah, it should work, but except that what if there is a 1, 1, 1, 2? If that's the case, I said the first one is it here matches, and it doesn't match here, so we return 2. It is not right. It is not right because considering the duplicates, I cannot compare this anymore. I need to calculate. I just to ignore the duplicate one. So I said set count of duplicates 0. If they're same, I can ignore it. So if nums I equals nums I minus 1 plus count it and continue. And then every number should be different. And now we need to compare it, plus it, the count of duplicates. If there's 1 duplicate, when I found 2, if there's duplicates, then wait a minute. This should be nums should be duplicates. Wait a minute. If it's not this is 2, it's okay. Should be 3. Be 3. Oh yeah, I shouldn't count like this. I think should count just the current number. If it's 1, the next should be 2. If it's duplicate, I just ignore it. So the current was 1. Okay, so if nums I equals current, then let's say target. Next one should be target. If it is target, if it's target, then we set target plus 1. Right, and then we just to keep found the target. If it's the same, it does not match, so it doesn't matter. So we go to the next one and go to the next one until the traversal ended, and we can check if target matches. Like 1, 2, 3, and target finally it would be 4, right? Yeah, next one is 4. So if we can just return target. Yeah. Let's try. Yeah, it should work. It does not work. It's not working. So for 2-1, why 2-1 is not working? So the target is 1. The first is 1, so target is 2. And then it got 2. And then target should be 3. I return. Wait a minute. Let's just add some log. So the target is 1. The numbers are. It seems that the numbers are not sorted. Ah, God. It should be positive numbers, my man. Yeah. Yeah, it passes, but actually it does not satisfy our needs. So I'll say this one is sort first. It doesn't count. We should improve it. How can we improve it? The things that actually I did some problems before corresponding to the real values related to the index. It's kind of like we're expecting the first number to be 1, the second number to be 2, the third number to be 3, right? Actually, we're expecting that kind of array. But why not just we move the number to where it should be, right? So that with that we can do it with one pass, and just to sort them out. Yeah, actually, if another observation is that the number should be within the length of this the possible missing positive integer would be within the length. It's smaller than the length, all right? So I just write down the observation. The missing num should be smaller or equal to nums.length plus 1. Yeah. The best case is that every number is right at their position, and we can expect that the missing one should be just one number right after the array, which means the nums length plus 1. Yeah. So when we are trying to find the right position of 7, we just can ignore it. There's no position for 7. And for -1, yeah, we can just ignore that. Just skip it. There's no place for them. We don't need to do that. Okay. So when we are moving the number to the position of where they should be, we just swap them. Like swap them to where they should be. Like for this one, at first I'd say there's 3, so we move to 3, swap it to -1, 4, 3, 1, right? And next, because the first one is changed, we just continue check. Because it's -1, there's no place for it. We just continue check number 4, there's no place for it. And then we check 3, it's right it is. We'll just go to number 4, 1. We move to 1, so 1, 4, 3, -1. The value numbers is 1, 1, 3. The invalid numbers are just at the original position. It doesn't matter. Now we can do one pass to check. Okay, the first one is 1, second one is 2, right? Yeah, it's okay. What if there is a duplicate? Okay, so there's like double 1. It's like this, right? And then we go to 1. There is 1, so we can. This is also invalid. We can just skip it. So after this swapping, we can just do it, complete this task with with one pass. Okay, so let's say the time complexity. So every round we just move one number to the right position. So it's actually on plus a one pass to check the possible missing number. So it's on. So actually on right just what we want, right? The requirement. And the extra space we just swapping to items. They're only constant extra space. There's only one variable is needed. So let's do that. So we need to first move them all to the right positions. This should be done within the while loop. I'll close this. Okay. An extra space to move it to the center. Okay. So the number, if it is not what it should be, if it is not at its own position, we should swap it, right? So we check first if it is right at the position. If it is at where it should be, nums I. If it's not equal to I plus 1. If it is at the right position, we can just skip it, right? Yeah. Oh, and also that for this one, the position it should be here. So we should ignore this also. And if it is not at the right position, and the position should be nums I minus 1, right? So this is the right position for it, for the original number for this one. So it should be 0, but it should be different than that. Nums I should not be equal and not at where it should be, and the place for it is not occupied. Yeah, then we do the swap. We swap with the swap current number with the number at its place, which means like 3. The place for it, it's -1, right? The position here, we just swap these two. But after we swap, the number for the index I is changed, so we need to keep it there. So we need to -1 because I plus plus will be done at the end of the each round. So let's swap it. So next one, so next index, like let's just say j will be nums I -1, right? Okay, I say that next the position should be like this. Right position should be nums right position. The position for nums I would be here, and if it's not a position and the position is not occupied by another duplicate number, then we swap it. So do the traditional traditional swapping. Nums I equals, so nums I equals nums right position, and nums right position equals temp. So after this, after all the loops is done, every number is at the where it should be, right? No, because for 4, this position should be within the range, right? So the right position should be bigger than 0, should be bigger than 0 and smaller than nums dot length. Yeah, after this done, everything as set where it should be, and we check it again. So so now I here, and also we can check if it is right at where it should be. If it is not, we just return I plus 1. And finally, if even this cannot, if even this is done, it means that 1, 2, 3, 4, 5, 7, right? So we can safely return nums plus 1. Let's test the code. Yeah, it's accepted. Yay! It passes. And the time is like on and a space. We only use this variable, no special data structure, so it's O constant. Yeah, this is our solution. The lesson I can learn from this is that when we are handling something like the array, searching something, and if the problem is related to the index, we can just try to move the number to the right index. And it will save us a lot of time. Yeah, at first I thought it was sorting would be perfect, but we don't need to sort. How we can save time from this by changing the sorting method to this one, to this swapping is because if like 7 to 5 12, it's out of range. It's not within our expected range. We don't need to sort these invalid numbers, right? So this swapping will save us a lot of time. It's kind of like backtracking. We don't need to sort. We don't need to consider all the cases, but we can terminate the process if we find some conditions unmatched. Okay, so that's all for this problem. See you next time. Bye bye.